Hey gang, welcome back. Here is example number 2. Take a look at it. Here we have a question asking us to calculate the current required to make 21.3 grams of chlorine gas from the molten sodium chloride solution in 80 minutes. Now we could go back, we could look at this one again, or we can quickly just figure out which reaction we're supposed to use. But if you think about it, we are trying to produce chlorine gas. All right, so there is a shortcut for those that are seeing it already. If not, let's just quickly explain it. So if we had molten sodium chloride, you have Na+, in liquid state. And you would have chloride ions in liquid state. There's your OA, there's your Ra. Obviously, you just have the one of each. Okay, so with that, then your OA gets reduced. Therefore, Na+ should gain an electron and form solid sodium. Well, that's not producing any chlorine gas, so obviously it has to be the chloride oxidation reaction that we're looking at. So if you took a look at your SRA and your oxidation, you have 2 chlorides according to your sheet. They're in liquid form, and then they would give up 2 electrons to form Cl2 gas, and that is the one that we want. So if I just quickly rewrite that, just so I have some room to work, 2Cl- gives me 2 electrons and chlorine gas. Now I can go back to my question and I can write down my associated information. I'm trying to make 21.3 grams of chlorine gas. Okay. And I'm looking for the current and an 80-minute time frame. So that should be applied to my electrons. I'm looking for current, which is given as symbol I, measured in amps or coulombs per second, and I have a time of 80 minutes. All right. Usually it's just easiest to start with your given information. We were given information about chlorine to find out information about electrons, so I'm just going to start with that. There are other starting points, as you guys might see them, but again, at this point, it's just your comfort level. So we have this as our starting point, and now I'm just trying to get to moles, so I can use my mole ratio, and then build the coulomb per second on the other side. So 21.3 grams of chlorine, I can turn that to moles easily. If I just use its molar mass, remember it's Cl2, so that's 70.90. Grams are now gone. I have moles of chlorine. Now I can do my mole ratio. All right, I want to get rid of chlorine, and I want to get to electrons, and you can see it as a 2-to-1 ratio. Chlorine's now gone. All right, now I have moles of electrons. Hey, something else has moles of electrons. That was Faraday's constant. All right, so moles of electrons and coulombs. For every 1 mole of electrons, there is a charge of 96,500 coulombs. That is also the starting part of 1 ampere. The only thing I have to also get in here, if you recall, is that amps is measured in coulombs over seconds. I just need to get time in here. So I have 80 minutes. All right, so if I put this over 80 minutes, all right, now I have coulombs per minute. It's coulombs over time, but I want to get that into seconds. And so remember that every 1 minute is 60 seconds of time. Minutes now go. And now I have coulombs over seconds. Okay, I now have the current flow. I just have to run this through my calculator, so you quickly do that one, and it should work out to 12.079 coulombs over seconds. So therefore, in 3 digits, this is 12.1 amps. Not too bad. All right, let's move on to example number 3. It's more of the same. One, we just have to figure out what our half reaction is and then apply our information. So in this one here, it says calculate the number of hours it would require to plate 5.87 grams of solid nickel onto a hubcap from a 2 mole per liter nickel 2 chloride solution using a current of 0.500 amps. Now this one's throwing a lot of information at you, and you're going to have a decision to make as to how you're going to start this one. All right, so I'll probably leave this one to you, maybe half started, and we'll see what you guys do with it. All right, but we now need to plate solid nickel. So that sounds to me like the reduction of nickel 2, right? We want to make solid nickel. So we find our nickel half reaction. There it is. There's your solid nickel. So if I reduce by giving electrons to nickel 2, I do reduce and get that solid nickel. So this is my half reaction that I can use for my cell stoich, Ni2+, plus 2 electrons goes to solid nickel. All right, so remember, cell stoichiometry has this nice easy exception because we need to see those electrons, so we only really have to assess half of the reaction at any one given time. Now we were told that we had a 2 mole per liter concentration of nickel 2 solution, that we have a current of 0.500 amps, remember that is also coulombs per second. We're looking for time now, and we are trying to get 5.87 grams plated onto the hubcap. So, I want you guys to solve this one on your own. There is one more video coming with a couple more solutions and a couple more hints to you. But try this one out. You have to decide. What are you going to use? How do you want to start this one? Which was the more appropriate starting point? There is a good reason there, but I'm going to leave it to you. The correct answer is in the notes. It's 10.7 hours, so you'll know if you get it. But I'll finish this solution in the next video.